Hey there, this is Tom Oden, and this is a run-up of my Minimax algorithm for SimacoGo. Alright, so get right to it. I'll run the game. My interface asks a couple quick questions. I'll play at apply of, let's say, 9, and we'll turn on alpha, beta, and proving. And it asks if you want to lose. If you want to lose, I took a suggestion from another student, Uchena, who said she implemented something where the algorithm would block your move every time if you selected this. We won't do that right now, just to show general game run. So you're prompted with open board, the score, and prompts you for a move. So we'll go in the middle of the board and do 5, and computer's taking some time to think. It responds with a 1. I'm still running into the same issue as before, and I saw a lot of other students where that the algorithm will tend to stack up columns, even if you block it. Like I'll put in 1 this time, and it still responds by working its way up the column. So that's how the game works. Don't want to go too far over with that. Stop that right now and go into the code. Modeling the game. So I tried to model most of my work inside the node. I used a char 2D array to hold the board, and I recorded the scores. I saved a value that represented the min-max, heuristic value, and it's also what would bubble up in the tree. I had room for alpha and beta values. I'm not using those because those took care of themselves in the algorithm. To have a successor function go, I went through each column on the board, tried going down that column to see if there was space for a new child, and then made the child. For the minimax and alpha beta pruning, I kept that in the same class, minimax, and when you call the minimax class, you decide and checks whether it's alpha beta pruning or non-alpha beta pruning, and then spins off the algorithm by calling the first depth minus 1, so the min end of it. And for minimax, I took this pseudocode for minimax from Wikipedia and the book. Do a terminal test, or if the depth is 0, and return the min-max value of the node. Otherwise, create all the children and set its best move to either the max of the child, or infinity, or I'm sorry, the minimum value. So minimum value goes up, maximum value goes up for the other end of it. For alpha beta pruning, I ended up using the pseudocode from Wikipedia first and switched over to the book. They both kind of did a couple of things differently in terms of comparing alpha and beta, or best value in beta, and same thing down here. So I ended up going with the textbook's pseudocode, and I percolate up. Start from either negative infinity or positive infinity, and percolate up via recursion that value for the tree. One thing I noticed is that if I did, allow the player to make, guarantee a loss, this was the logic I used to block them. I basically said, okay, if all minimax values are the same, once they've percolated up to the first branch of children, then find the human player's last move and just block, put the tile on top of there. And that worked pretty well, but it made me realize that a lot of the values returned from minimax were equal to each other. So I might try checking into that next time, storing node values in a smaller data structure, maybe in a byte array, or using a priority queue of minimax that was mentioned in the book to go down further in the tree. So yeah, that is the Minimax and SimacoGo algorithm. Thanks.